Hello, so today we are going to try to solve this problem, longest mountain in an array in Ruby. So the problem says we have a contiguous subarray B of A, which is a mountain if it has the following properties. The length has to be bigger or equal to 3, and of course you need that so that you could have like a lower point where you go up, and then from the higher point you go down, so you need 3 points at least, so you need three elements, right? And then we want to return the longest one, the longest mountain, and if there is no mountain we should return 0. And in this example the longest mountain is this one, so we go from 1 up to 4 and then up to 7, and then we go down to 3 and down to 2, and that's the longest mountain we have. From 2 to 5, that's not included because we are going to go up again. So a mountain is just going up, reaching a peak, and then going down. And then for this one where they are all equal, it's 0 because there is no mountain there. If you also had 2, 3, it will be just going up, so it's not a mountain either in that case. So let's try here to solve this one. So what I'm thinking of doing is just have 2 arrays, right? So one that keeps track of, so up and down. So up will keep track of for basically the by how much did we go up for every point, and down by how much did we go down for every point. So for example, if from 1 to 4 we went up by 1, so it would have 1, and then we go up again 2. We go down, so we go down by 1 and then down by 1. And for these cases where we are going up, down value would be 0. And so if we do that, if we have the increasing amount every time and then decreasing amount, so for example that would be for 7, and then we have 7, 3, 2. This is the mountain, so we just need to find where they meet, right? So that would be, so this is going down, and so the value here would be, we'll start out with 0 and then we will go up, so 1 and then 2 here, right? So this is the up value, right, for these. And then the down value for these would be, well, we are just going up, so it would be 0 for all of them, so that would be 0, 0, and then 0 here. And then for the, maybe let me just put the entire mountain here, 3 to 5, let's just go all the way to here. So this would be for these. And what about here for this 2? So for 2, there is nothing before, so that's 0. And then from 2 to 1 we are not going up, but we are going down, so here it's 0, 2, but here we are going down, right, from 2 to 1, so it's 1. But since here we are not going down, it's 0. And then from 7 to 3 we are going down, we are not going up, so 0. At this point it's 0, 2, and then at this point it's 0. And then if we go here at 3, we are from 7 to 3 we are going down, so that's 1. And then we are going down again, so we increase the previous one, right? Because at each point it's how much, by how much are we going down, like the length of the decreasing values, right? And so here, or the decreasing subarray, and then here it would be 2, and then it decreases again, so we increment the length of the decreasing subarray. It also has to be contiguous. It is contiguous in this case, so we have 3. Okay, so how can we find the solution here? So actually what we need is, we need to do this down from the going from the right, because if we do it this way we won't be able to solve it, I think. So what we need to do here is, okay, so we are at the far right here, so that will be 0 here, and then we will be here, and you notice that from 2 to 5 that's not decreasing, that's increasing, so we have 0. But here from 3 to 2, that's increasing, so that's 1. From 3 to 7, so 7 to 3, that's decreasing again, 2, right? And then from 7 to 4 and 7, that's increasing. For 7, you go down, so you go up, so that's 0. Here, 1 to 4, that's going up, so 0. So for down, we are going to go right, from right to left. And then for 2 here, that's 2 to 1, that's decreasing, so that's 1 here. And so you can see here what we want, the places we are looking for, which are the peaks of the mountain, are those that have both up and down values positive, right? So when up for a position is bigger than 0 and down for I is bigger than 0, that's the peak. That's a mountain peak. And so that's where I want to be looking at, right? So that's where I want to be, where I want to compute the length. And so I compute that length at that point and take the max of all of these values, right? And so basically the length would be just up of I, right, plus down of I, plus 1, right? So because remember, this is the size of those to the left, and this is the size of those to the right, and now we need to add the peak itself. And so that would be 2 plus 2 for this case, plus 1, which is 5 that we want here. And so this is what you need to return, right? And so what we need to consider as a possible maximum mountain, in this case, it turns out to be the maximum. And so let's make this here. So we need an array, both up and down. And so we'll need to initialize them. So yeah, can we initialize Ruby initialize array with zeros maybe? Okay, so we could just use something like, let's see here. So let's switch to ARB. And so if we do something like array of, so we can give it the default value and the size. So let's say the size is 5 and the default value is 0. We'll get that. So that's what we are looking for here. So let's just initialize that. So we want an array of size, the length of A. So let's say this is size. So n default value is 0, and same thing for down. And now we need to iterate, right? So we need to iterate from the left to the right for up. So that would be, so iterate left to right for up. And then we need to iterate right to left for down. And from there we could here, then we will process the result. So we'll do 3 passes, right? And so to iterate from left to right for up, what do we need to do? So let's see. So we need to do to go from 0, right, all the way to n. We don't want n included, so we do 3 dots, and then we are going to say for each so, and then what we want to do here is say that if, so we are going to increment I only if it's increasing, right? So that's what we did in the example. So if the previous element is smaller than the current element, and so for this to work, we need to start from 1 and go all the way to n minus 1. And then that's pretty much it for the left side. and then we need to do something similar for the right, but we need to go from the last element, so n minus 1, we need to go all the way to 0 inclusive, and then we want to do each I, and we want to have, this is probably not idiomatic Ruby, but yeah, let's try to solve it first. So here what will happen is that we need to rely on the previous one because we are going from the right. So down I plus 1 plus 1. If what should happen, we need the first one, we need the last one. Basically what we need is this, we need the last one to be smaller than the first one, right? So we need a I to be last one, right, to be smaller than the first one. But just to have symmetry here, maybe I should do I plus 1 here and then do I here. So I want the last one to be smaller, and with this do the boundaries work. So one problem here is that this will give me a negative value, because if I do, yeah, I will need it to be negative so that I can decrement down. So, and then here I can just say this is j, and say that I is equal to minus j. Let me show you why I need that. So, because if I do just 4, 5 to 0, how can I, yeah, let's take 6 of these so that we can get all of them. So I get an empty array because that's not possible. But if I do minus 5, you can see I get them, and so I just need to do minus so that I can have them in positive values. And it will be basically indices going from right to left. And so with that, I would start here with the last element index. And so I plus 1 won't work, right? So what I actually need is for I minus 1 to work, I need to start from minus 2 here, so that this would be the last element. And then for 0, this would compare it against 1, so that should be fine. And now I can just get the max, right? So for that, I'll just iterate through. So I need to do from 0 all the way to n for each. So I'll get I here, and I'll need to go and compare up, basically check if so I need to have the result here to get the max. So I'll say result starts out as 0, and then I would need to max of res. So res will be assigned to this, and up of I, basically what I said here, which is the length, but I will guard it by this condition, right? I need both to be positive for me to be at a peak of a mountain. So I would say if up I is bigger than 0 and down I is bigger than 0 as well. So if both of these are true, then we can pick the max and just return that here, the max length. So yep, so it's actually not A, but let's just move it to make it A. Yeah, let me just keep it A here, use A here as well. Okay, let's try with this example. So for 5 doesn't seem to work. let's try to print both up and down. Just get rid of the second example. Yeah, it looks like the problem is in down, even though, yeah, this like displays it vertically. How do you string interpolate in Ruby? Okay, so we need something like this. And then same file down, up here. Okay, so the problem is in down. It seems like, yeah, I forgot +1. That's really bad. Yep, so sometimes the size is empty, right? Or so there is undefined max. Yep, so in Ruby we need to do this to get the max. Convert it into this and then do dot max. Okay, so that does look good. Let me just comment these two. Okay, so that passes. Cool. Cool. So it's just getting the up subarray sizes and then the down subarray sizes, and then finding the peak points where they meet and getting the length, and for all these occurrences finding the max length among them. Okay, so I improved the solution here a little bit, where instead of using brackets as before, I'm using do and end for both here, and instead of using the minus thing here where I had to do minus j here and do minus j, I equal to minus j, I just use down to and up to, which makes it easier. And they just, for up to, it just goes from 1 up to n minus 1, down to it goes from n minus 2 down to 0, which is what I'm looking for. And now what's remaining is this. So can we make this portion here better? So essentially we want to take the max of all of these, right? So maybe we could just map, or maybe we could just do zip both and map them. So let's see if Ruby has zip. Yep, it does. So I could do something like one, two, three does zip 4, 5, 6, and that gives us a pairing of each with the other one. And so that's what I want with up and down here. So let me try with up, let's say 1, 2, 3, and then down equal to 4, 5, 6, and we'll say up dot zip down. So that will give us the values that we want to get the max, that we want to sum here. And so we need to apply kind of a function to this list, right? So I could just say this is list, and maybe say list dot map, or let's look up map and Ruby. Okay, so I just need to take the list and do the map. So list dot map, and I'll get here both So for a pair, it will be values, right? And so we could just, here we'll need to just say values, that sum plus 1. And so 5 plus 1 and then 7 plus 1, you get the idea. And now we would have that. So we have this portion here. Now we just need to take the max for all of them. But we need to also say if both are positive, right? So we need to filter out when both are not positive. So filter, so we need to use so select, that's what we are looking for. So we need to select, so check elements positive. So we could just select and just use something like that where so that will give me something like this where I have values, and then I could do something like values dot all, which is the method here that will give me, and then I could pass a proc here for negative, so positive for, in this case, that's what I'm looking for. And let's just first check if that is correct. Okay, so first I need to append a -1 so that I can make sure it works. So 2, and then now list contains that one. So if I filter, it no longer contains the negative value. And from there I could start mapping to get, let's call them values. And then I want to get the sum, and then add 1. And now that I have those, that's what we have here. We want to take the max. And so, well, the max should be easy, right? So it should be just that. So we need first to get the what list is, which is just this, right? So the final result, we can just get rid of all of this and then just select positive values and map and get the max. Okay, just put this down a little bit. Max at the end. Okay, so that looks good. Yeah, so the problem is when the list is empty. So, so maybe we could do something like this and then say then res. So we can do 0 if it's null, otherwise we return for s, right? Check that we need to pass to here. Okay, so that looks good. Let's submit. Okay, so that passes. Yeah, maybe there is a way to improve this portion. Okay, so I think we could do something here where we don't need to do this return here. So I could just do this or 0, which means if it's null, it will give me 0, right? I could also just write it down as or. Not sure which one is more idiomatic, but so we'll be using or. Okay, so it seems like, yeah, I remember reading that somewhere else, so let me just stick to this or. And I think this should be it. Okay, so this is better, cool. So yeah, I think this is good enough. Cool. Okay, so let's see if we can improve this solution here a little bit. So I'm thinking maybe we could use, so we have up and down and we have this portion here, right? Sorry. So we need IRB and let's try to take this here. Yeah, I need to define both. So let me define just up to be maybe something like this and then down to be something like 0, 1, 2, right? So that would give us this, and maybe we could use select map, filter map, I think. So filter map, we could say if, and then do values that sum plus 1. So basically just combine the map and the select at the same time. I think it exists, filter map, Ruby. So it exists on enumerable. So it's, what's the type of zip? It's an array, right? So up dot zip down. If I do class, it's an array, right? So it's not enumerable, but it should work, right? So filter map, right? And find. What's the type of Ruby array? Does it kind of supports? It doesn't support all enumerable methods. So array to enumerable, maybe. Or maybe I can just do map without the filter, right? So what if I just do map with if? So if we do that with compact, we actually get it. But yeah, that's an alternative way of doing it, but it's not it's not better, right? It's not. So you could do like map here, and then do values that sum plus 1 if that is happening, and then just do compact here. But still, I don't. That's not better. What about doing each here without the compact? Let's see what each. Yeah, this didn't do anything, right? Yeah. Okay, cool. It passes. It's not better, but it's a different way of doing it. So yeah, I think this is good enough. Cool.